that's new at all, right? Really, all today is going to be about is why are we factoring, right? Like, what do we do? Like, what's the point? Okay, if I say factor, what are we really accomplishing? Why do we need to? Why would we want to? Okay, and so here's the thing, right? The law that I'm going to show you guys is called the zero product law, and it's one that you guys learned when you were literally probably in second grade, right? If I was to take the number 3 and plug it in here, right? What's 3 minus 3? 0, right? And then if I plug the 3 here, it's 0 times what? Times 10, which makes this equal to 0, right? So can we all agree that 3 would be a solution to this problem, right? But can we also agree that if I plug what number over here? -7, right? Because -7 plus 7 is 0. And does it matter what this even is once I do that? No, right? So we know that we have two answers, right? We know that we have two answers. All right, down here. All right, in part B, what do we know this answer is going to be? What can I plug in so that x minus 4 equals 0? 4. All right, and then this one's a little bit more difficult, right? This one's a little bit more difficult. And so we think of the technique now where what? Well, how did you guys get the number 4? How'd you get 4? Well, I mean, it's easy, right? It's easy. You just simply said what? You said, well, I know that I'm subtracting 4, and so 4 minus 4 gives me 0, right? You just kind of figured it out. Well, guys, isn't that really what algebra does, right? What number minus 4 equals 0? Well, how do you solve that algebraic equation? You add the 4, right? And that's why we got this solution, okay? Well, can we repeat an algebraic process over here, right? If I have 2x minus 5, and I want to know what value of x makes that equal to 0, that's just an algebraic problem now, right? Add the 5. And divide by 2. And so we get x equals 5/2. Be careful with this here, guys. How many factors do I have here? Give me the number of factors. All right, well, okay, you can guess if you're not sure. 3. 3, because 4 is a factor. Remember, factors are things that are being multiplied together, right? So 4 is a factor. 3x plus 2 is a factor. 4x minus 3 is a factor, right? Well, guys, if I plug something in here and I get 0, what's 0 times whatever it is times 4? 0. If I get a solution for this, and that solution gives me 0, what's 0 times this times this? 0, right? So does the 4 really have any bearing on the problem at all? No, no, it doesn't. All right, so I have two algebraic equations based on the two factors that have variables, right? And so here I get an answer of -2/3. And here I get an answer of 3/4. That cool? So again, I want to stress it, guys. Did this 4 have any bearing on the factors and the solutions of the problem? No, right? Because 0 times 4 is still 0, right? This 4 doesn't matter. I do want to add one example to this. And the example I want to add is this one. So just kind of off to the side, you should have a little bit of room. How many factors do I have here? I still have two factors, right? I still have two factors because again, what do factors do? Multiply, right? So here's one thing being multiplied by two by this thing, right? So I think we can really easily agree that this is going to be an answer of -1, right? And if we want to set it up, there's our answer of -1. All right, guys, how is this problem different from the one that I just did? Here there was a 4 in front, right? Here, what's in front? A 4x. Is it possible for 4x to equal 0? Yeah, if x is what? Is 0, right? So if there's a variable out in front, then that's going to make a difference, right? If there's a variable out in front, that is going to make a difference, okay? Are we okay with that? All right, I already answered this question in example D. All right, let's go down here then. All right, so I want to use the zero product law to solve this, okay? And your first thought should be what? Well, it's not telling me that it's equal to 0, is it? It doesn't say equal 0 like these examples did up here, right? Well, what can I do so I can use the zero product law? I got to move this over and I got to move this over so it is equal to 0, right? So our first step is to get the equation equal to 0. Right? So we got to do a little bit of algebra. All right, so I'm going to add the 2x and subtract the 10. And that gives me an x squared plus 5x minus 24 equals 0. Now it's equal to 0. Okay. Guys, how does it still not look like one of the problems from above? What did all the problems above look like? They looked like they were already what? They were already factored, weren't they? This one is not. So what do you think I need to do? Factor it. And I'm going to use a word here, guys. Factor the quadratic, right? Factor the quadratic. All right, so let's take this. And it's going to be one of these, right? No GCF. What do you got, guys? Give me two numbers that add up to be 5 and multiply to be -24. So if you got to list them all out, great. If you got to go to Control T, great. But I need factors that give me -24 that add to be 5. All right. I hear an 8 and a -3. What's 8 times 3? 24. One's positive, one's negative. So do I have my -24? Yep. And if it's positive 8 minus 3, is that 5? It is. So those sound good to me, okay? X plus 8. X minus 3. All right. And then we take both of those, right? And we set both of those equal to 0, right? And that's our little trick. All right, so I have an answer of -8. and positive 3. And again, guys, I'm going to use a word, right? So, oh, hang on a minute. So we factored the quadratic, and then we set our factors equal to 0, right? Guys, what am I going to use for these? Give me some phrases for these. What are these things called? What did we just create? Okay, great. I heard zeros. Well, first thing I'm going to use is we found solutions of x, right? Those are solutions. If I say solve, those are the solutions, right? Those are the answers to the problem, okay? Now, what are some other ways that these might be referred to? I heard the word roots. I heard the word zeros, okay? Also what? X-intercepts, right? Because we already talked about the fact that roots, zeros, and x-intercepts all mean the same thing, right? So you found the solutions, you found the roots, you found the zeros, you found the x-intercepts. All in one step. Good? All right. What do we got here? Well, it's just got more things to move around, right? So our first step was to get it equal to 0. Guys, first step, once we get it equal to a quadratic, because we know that our actually off to the side, I think I'm just going to do this. We know that step 1 is to make it a quadratic equal to 0, right? So that was our first step, right? And then we know that our second step is to factor, right? But again, guys, when we factor, we always want to make sure that we follow the order of factoring, right? Which is to look for a GCF. Is there a difference of perfect squares? If not, is it a trinomial? If it's a trinomial, what do we have available to us? Well, we can either just factor it, right? Or we can use an AC method, or we can use a split the middle method now, if we want. And if it's, how many terms can we factor by grouping? If it's 4 terms, then maybe we can do a grouping problem, right? So again, guys, this is sort of, this is sort of like your playbook in a sense, right? When we have something that has a square in it, where it asks us to factor, or it asks us to find solutions, or where it asks us to find the roots, we got to get it equal to 0, and then we got to go through those steps, right? What kind of a problem is this? Is there a greatest common factor? No, right? So it's what kind of a problem? It's a trinomial, and that's a 2, so it means I have to go to one of these, right? Factors of negative 10. Which ones am I looking for specifically? Factors of negative 10 that add to be up to 9? Okay. Ten and negative 1. Yeah, 10 and negative 1, definitely, right? Definitely 10 and negative 1. Those are going to multiply to be negative 10, add to be 9. So I know for certain that it's going to be equal to 0. I know for certain that I'm going to have a plus 10 and a negative 1. And what goes in the front? 2x. Why 2x? Because it was what? It was a 2x squared, right? So I know that that's why I did an AC method to begin with, because this number wasn't what? Wasn't a 1. Anything I can do with the 2x plus 10? Take out a 2. Anything I can do with the 2x minus 1? No. Okay. How many factors do I have? 2, right? They both have x's in them, right? So what am I going to do with those two factors now? Set them both equal to 0. And those are my two solutions. I have a solution of -5 and a solution of 1/2. Guys good? All right. All right, so again, I sort of showed you a reason why we factor. I showed you the reason, and the reason right now is I can find roots. I can find solutions to an equation that involves a square, right? So what are some ways that I can ask you to now apply that technique? Well, here's one of them. Here I said, consider the following system of equations. When you see a system of equations, how do you know that it's a system? You have more than one what? More than one variable, right? And more than one equation, right? We did ones that had 3 variables and 3 equations earlier, didn't we? Okay. Well, here I have 2 equations and 2 variables. Okay. Well, what do you notice about both of these equations? They're both equal to what letter? They're both equal to y, right? So if y equals this and y equals this, then doesn't 3x squared minus 8x plus 5 equal 4x plus 5? All right, let's write that down. All right, and that's because they're both equal to y. All right, I'm going to give you guys 2 or 3 minutes. Go ahead and solve that quadratic equation. All right, here's what I got. Ready? Boom, right? So we're going to subtract the 4x. We're going to subtract the 5. 5 minus 5, that goes away, right? So I get 3x squared minus 12x equals 0. So there's my quadratic. Now I got a factor, right? Well, this is a GCF problem. Take a 3x out of both of them. When I take out a 3x, I'm left with an x minus 4. Set my factors equal to 0 and solve, and I get solutions of 4 and 0. Now, guys, did I finish the problem though? Did I finish? I see a couple of people shaking their head, and I see a lot of people confused. They're like, huh? Didn't finish the problem. Go back to the original. Consider the following system of equations, right? When I have a system, there are going to be answers for both x and y, right? So what did I just found? Or what did I just find? I found the x solutions, right? How do I get the y solutions? I now plug them back in. Does it matter which one I plug into? No, I can plug into either one. So I'm going to choose the one that's easiest, which is probably that one, right? All right, so those are my solutions of x. Let's write that down. These are my solutions of x. So there are two solutions of x, right? Okay, which means there are going to be two solutions of y. And to get those solutions of y, I'm going to plug in. And I get 5. And 21. Hi, Jamie. Now notice something, guys, right? When I plugged in the 0, I got a solution of 5. When I plugged in the 4, I got a solution of 21. Those are unique to each other, right? So what I actually want to do is this, right? These are my solutions of y. And now if I said, what are the solutions? What I actually want to do is this. 0, 5, and 4, 21, right? So I wrote those down as what? As coordinates, right? Because one of the ways that I could actually go about doing this, right? What's this? What's a system of equations? Well, a system of equations is not only where are x and y equal, but it's also where do they meet on a graph, right? Okay, so let's talk about that now. Could have done this problem algebraically, guys. Oh, I'm going to tell you right now, this will be a question on your exam, right here. No doubt. All right. So if I said to solve this problem graphically, let's go to the calculator. All right, and what do I have? Well, I have the equation of the parabola. And how do I know it's a parabola? Because there was a square, right? So I had this original problem. I want to go all the way back to the beginning. I want to know where those two things intersect on a graph, right? So I have 3x squared minus 8x plus 5. Let's put that in the calculator. And I get a parabola. And then I have 4x plus 5. And I have a line. Guys, how do I get that second one in there? What button do I have to push to add an equation? The tab button, right? almost like I've done this before, huh? Guys, I want to know where this red thing intersects this blue thing, right? So here's what we're going to do. We're going to, again, multiple ways to do it. I'm going to show you the way I like. I'm going to go to menu. I'm going to go to geometry. And I want to know the points of intersection. The reason that I like this, guys, is because all I have to do now is see how you move this around. Nothing happened when you did that, right? Except this thing up in the corner. So if you move this cursor around to the red line and click on it, and then move your cursor over to the blue line and click on it, check it out. What happened? It plotted one of the points of intersection. Now, why only one? Where's the other one? Well, it's up there, isn't it? I wonder if the calculator's smart enough to know, actually smart enough to find it if I just do a zoom fit, right? Because do you agree? It's like, it seems like it's going to be within these x values, right? So I think a zoom fit will probably show it to me. And I mean, it's not like, it's not great, but it definitely showed it to me, right? And so there's my solution of 0, 5, and 4, 21, okay? Now, here's the thing, right? Do we all agree that getting that on the calculator is not that big, not that difficult of a task, right? What is kind of a difficult task, though? Getting it from the calculator onto the paper, right? Well, here's what I know right now. I know there's an answer at 0, 5. I know there's an answer at 421. So I'm going to do this. Here's my y-axis. There's my x-axis. I already know one of the things, right? I already know the points where these things intersect. And we confirmed it with the graph, right? So I'm going to go to 0, 5. And there's that point, right? There's one of the points of intersection. And then I'm going to go to 421. And it's like up there, a little bit off my paper. 421. All right. Guys, I know that both the line and the parabola intersect here and here, right? So don't I know that the line must go through these 2 points? And if the line must go through those 2 points, can I just connect it with a line? Let's do that. All right, so there's my line, right? Sorry that that's yellow. That's the color it is. The parabola, guys. Well, how can I get points on the parabola? Make your life easy. Where do points exist? On the ground, is that what you said? Yeah, on the graph. But guys, where can I find them like listed for me? Yeah, go to the table. And it's the blue one, right? Color coded, how nice. So I got a bunch of points here, right? Let's just find a few of these points, plot them on our graph, and move on to the next problem. I mean, that's literally that easy. Let's just do that. 1, 0, 2, 1, 3, 8. 1, 0. 2, 1. 3, 8. Actually, it was 1, 0, not 0, 1. 1, 0. Did I plot that? Yeah. Okay, we're good. 1, 0, 2, 1, 3, 8, 0, 5, negative 116. We could put that on there. Negative 116, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Probably enough, right? Because what do I have to do, guys? I have to go through this point up here, right? Because that was one of the points of intersection. I have to go through this point that I just plotted. This point, this point, this point was one of the points of intersection. I got that point, right? I think that's enough to create a reasonably accurate graph. Good enough for me, right? And so this was y equals x squared, or 3x squared minus 8x plus 5. And this was y equals 4x plus 5. All right, so labeling them, I have my points of intersection labeled. And with the calculator, it's not too bad. How are you doing, okay? Leonard, are you okay back there? You got this? Bang. Dude, that was a kill shot. That was incredible. All right. Sample 35. Gave you a parabola, right? Look how nice of me. I even what? I even graphed it for you. Here's the equation. Write the two coordinates of the what? X intercepts, right? Do I have to do any work for this? No, they're right here. Boom and boom. How do I write coordinates of roots? Well, guys, those are x-intercepts, right? And don't we write things as x comma y? So this is the point -1 comma 0. And this is the point 1, 2, 3 comma 0. All right, so again, what happened? This equation looks like this, creates these solutions of roots, right? Or x-intercepts. If I asked you to do this algebraically, right? If I asked for you guys to do it algebraically, well, what would you do? You would take this equation and set it equal to 0. You would factor it. Two numbers that multiply to be -3, add to be -2 are -3 and 1. And there's my answer, -1, right? Mia, last thing of the day, ready? Yes, here it is. Algebraically, find the set of x-intercepts for each parabola given below. Okay, so what am I going to do? Set this equal to 0. Set this equal to 0. Set this equal to 0. That's all I'm doing, right? So I have 4x squared minus 1 equals 0. I have 3x squared plus 13x minus 10 equals 0. And I have 5x squared minus 10x equals 0. Take a minute, factor each of those, and find the roots.